the house. Today, we're doing Math Analysis, Chapter 5, Section 3, Part 2, the half-angle identities. I'm your host, Dr. D. All right, now, the power reduction and the half-angle identities. First, we're going to do the power reduction identities. And what this means is I'm reducing a squared trig term to a trig term to the first power. So the way I'm going to do that is I want to reduce sine squared. Well, I'm going to start with cosine 2 theta equals 1 minus sine squared theta. Now, if I add 2 sine theta over to the left and subtract cosine 2 theta to the right, then I have 2 sine squared equals 1 minus cosine 2 theta. Divide both sides by 2, and I have sine squared theta equals 1 minus cosine 2 theta over 2. So notice what we accomplished here is we started with a trig function squared, and we ended up with a trig function to the first power. So that's going to be handy in calculus next year. You'll love that. Okay, so the next one, we're going to do the same thing, only I want to go from cosine squared to something to the first power. So I'm going to use the cosine 2 theta again and use the 2 cosine squared minus 1. Well, I'm going to add 1 to both sides, divide both sides by 2, bam, there we are. Cosine squared equals 1 plus cosine 2 theta over 2. Now, take a look at these two identities. They're really similar. The only difference is cosine is the home team, so it gets a plus, and sine is the visiting team, so it gets a minus. That's all you got to remember. So it's 1 either plus or minus 2 cosine, or plus or minus cosine 2 theta over 2, and if it's sine, it's minus. If it's cosine, it's plus. Now, tangent, once you know sine squared and cosine squared, tangent squared is easy. You just go sine squared over cosine squared. So that's 1 minus 2 theta over 1 plus 2 theta, and the 2's cancel. And so that's it, 1 minus cosine 2 theta over 1 plus cosine 2 theta. So everything reduces to cosine 2 theta, whether it's sine squared, cosine squared, or tangent squared. Okay, now, this could be a good idea to actually memorize these three.
That's the smartest thing I've ever heard anyone say about anything.
Okay. Now we're going to do the half-angle identities. So we get our half-angle identities from cosine 2 theta again. Notice cosine 2 theta is 1 minus 2 sine squared. Now, if we let alpha equal 2 theta, then that means theta equals alpha over 2. So where I have cosine 2 theta, that's just going to become cosine alpha equals 1 minus 2 sine squared theta, which is alpha over 2. Now, what I'm trying to do is get the sine theta, or sine of alpha over 2 alone. So how do I do that? Well, first, I need to subtract I need to get the 1 out of here. So basically what I did was I put the cosine alpha over on the right as a minus, and then I added the 2 cosine squared, or 2 sine squared alpha over 2. Now what I do is I divide both sides by 2, and then I take the square root of both sides. Now what does this give me? This gives me sine of alpha over 2. So it's sine of a half angle. That's why we call it the half angle identity. And it equals plus or minus square root of 1 minus cosine of the full angle divided by 2. Now, the plus or minus, you're going to determine what that is based on what quadrant the angle's in. So let's say alpha equals 120 degrees. Well, alpha over 2 is 60, and sine of 60 is a positive term, so you'd use the plus. Okay, so let's do the same thing with cosine 2 theta equals 2 cosine squared minus 1. So alpha is going to be 2 theta, and theta is alpha over 2. So now I have cosine of alpha equals 2 cosine squared alpha over 2 minus 1. Now, the goal, once again, is to get the cosine alpha over 2 alone. So what we do is we add 1 to both sides, and I put the cosine squared on the left. So now I divide both sides by 2, take the square root of both sides, and there I am with cosine of a half angle equals plus or minus square root of 1 plus cosine of the full angle divided by 2. Now, the key thing to remember here is they both have cosine in them. Sine of alpha over 2 or cosine of alpha over 2 both use the cosine. The sine is the visiting team, so it has a minus, and the cosine is the home team, so it has a plus. So notice this is really similar to the power reduction identity. Notice all we did here was it's just the square root of both sides. But this enables us to get half angles that we wouldn't know what the full, we do know what the full angle is, we don't know what the half angle is. So we'll do some examples, you'll see what I mean. Okay, now, oh, one other thing I forgot to mention then. Tangent alpha over 2 is going to equal sine over cosine. So let's just write that in here. So tangent of alpha over 2 equals plus or minus the square root of sine, which is 1 minus cosine alpha, over cosine, which is 1 plus cosine alpha. And notice the 2's cancel. So there's our third half angle identity. Okay. So now write 8 cosine of the fourth x in terms of trig functions to the first power. See, this is using our power reduction. So we're going here. So we're using that sine squared is 1 minus 2 cosine, or 1 minus cosine 2 theta over 2, and cosine squared is 1 plus cosine 2 theta over 2. So they're asking us then 8 cosine of the fourth x. So we have 8 cosine squared x cosine squared x. Now, cosine squared x is going to be 1 plus cosine 2x over 2 times 1 plus cosine 2x over 2. So notice what we have here is the 2's on the bottom are just going to be 2 times 2 is 4. 8 over 4 is 2. So we end up with 2 times 1 plus cosine 2x times 1 plus cosine 2x. So that equals 2. Now, when I distribute this, it's going to be, it's a plus b times a plus b, so it's going to be a squared plus 2ab plus b squared. So when we distribute this, we've got 2 plus 4 cosine 2x plus 2 cosine squared 2x. All right, now, notice the instructions. We need trig functions to the first power. We still have a trig function to the second power. So we need to get rid of it. And so we say that, let's just put down here, cosine squared of 2x equals 1 plus, now cosine 2 of 2x is going to be cosine 4x over 2. See, it's 1 plus cosine 2 theta over 2. Well, theta is 2x, so 2 of the 2x is 4x. So now our final, the final answer is going to be 2 plus 4 cosine 2x plus 2 times this thing. See, so all we did was cancel the 2 over 2, and now we just add up the 2 plus 1 is 3 plus 4 cosine 2x plus cosine 4x. And that is our final answer. Now, at this point, you're not seeing the utility of this. Like, what good is this? Well, when we integrate this function, it's going to be much easier to integrate the cosine when there's no power there. So you'll appreciate it next year. Okay, cruising onward. Now this one, we want to verify, or basically solve for these values using the half angle identities. So first one, sine of 75 degrees. Well, I could do the sum of the angles. So I remember 75 was 45 plus 30, and I know sine and cosine of 45 and 30. This is a new technique now, and it's actually a little simpler. We can make this sine of 150 over 2. Now, 150 becomes our alpha. So sine of alpha over 2 equals plus or minus, we'll just keep the plus or minus for now, plus or minus the square root of 1 plus cosine alpha all over 2. Now, sine of 75 degrees is positive because 75 is in the first quadrant, so we really don't need the plus or minus anymore. And then cosine of 150. Here's a 150 degree angle right there. And what's cosine? negative square root of 3 over 2. So this whole thing becomes the square root of 1 minus square root of 3 over 2 all over 2. Okay, so this is, what I'm going to do is get a common denominator on the top. So it's going to be 2 minus square root of 3 all over 2 all over 2 under the radical. Now, when I flip the bottom and multiply, and that gives me square root of 2 minus square root of 3 all over the square root of 4. So that's it. That's as simple as you can make it. And the interesting thing is, if you do the sum of the angle, angle sum identity, then you'll get the same thing. It'll be a decimal equivalent. Okay, now let's try cosine of pi over 12. We need to get our brown back. Okay, so cosine of pi over 12 is going to be cosine of pi over 6 over 2. See, we don't know what cosine of pi over 12 is, but we do know what cosine of pi over 6 is. And pi over 6 over 2 is pi over 12. So we plug this in the identity, and so it's going to be plus or minus. Oh, rats. I screwed up. Okay, this next exercise, we're going to be using half-angle identities to find the exact values of the angles that we don't know. So, sine of 75, I could use the sum of the angles and make that sine of 45 plus 30. But here's a new technique where I'm making it sine of 150 over 2. Now, the cool thing is I do know what sine of 150 is. See, here's 150 degrees, and sine is 1 over 2. So sine, and cosine is square root of 3 over 2. That's actually what we're going to need. So sine of alpha over 2 equals plus or minus the square root of 1 minus cosine of alpha, all divided by 2. So notice, sine is the away team, so it has a minus here. Now, cosine of the 150 degree angle is square root of 3 over 2. The other thing we need is sine of 75. Well, 75 is actually in the first quadrant. So that means it is positive. So we don't need plus or minus. We can just go with plus. So it's the square root of 1 minus negative square root of 3 over 2. So 1 minus cosine of 150 is negative square root of 3 over 2 all over 2. Okay, so let's make a common denominator on top. So it's going to be the square root of 2 plus square root of 3 all over 2 all over 2. Notice all I did was go minus a negative is plus, and then the 1 becomes a 2 over 2. So 2 plus square root of 3 all over 2 all over 2. Now, when I flip the bottom and multiply, I have 2 plus square root of 3 over 2 times 1/2. And so this equals the square root of 2 plus square root of 3 all divided by 4. Now, the square root of 4 is 2, so the final answer just becomes 2 plus square root of 3 all divided by 2. That's it, piece of cake. Now, when you do the sum of the angle identities, you'll get an equivalent expression that will turn out to be the same decimal equivalent in the calculator. Okay, next game, we have cosine of pi over 12. Now, cosine of pi over 12, the easy way to do this is to just say this is, I used the wrong brown, how embarrassing. Okay, this equals cosine of pi over 6 over 2. So alpha over 2. So once again, this is in the first quadrant, so it's positive. Cosine is positive in the first quadrant, so I'm not going to go plus or minus, I'm just going to keep it plus. Now, it's 1 plus cosine alpha all over 2. Now, cosine of pi over 6, here's pi over 6, and cosine is square root of 3 over 2. So that means we have 1 plus square root of 3 over 2 over 2. So notice it's basically the same thing as what we had over here. So we know that the whole thing ends up being square root of 2 plus square root of 3 all divided by 2. Because notice, pi over 12 is actually 15 degrees. So what we just did was we went sine of 75 and then cosine of 15. And sine and cosine of complementary angles are equal. So that's happy. All right, now, for the tangent, we're going to go completely off the grid and go to 5 pi over 8. Well, that's going to equal tangent of 5 pi over 4 over 2. Because remember, we're trying to get the 5 pi over 8 into a fraction of alpha over 2. Now, how do we do this? Well, notice what we've done every single time. You double your angle and then divide it by 2. Double your pi over 12 and it becomes pi over 6. Then cut it in half. Then double your 5 pi over 8, you get 5 pi over 4, and then cut that in half. So we've doubled it and then cut it in half. And now, do we know what tangent of 5 pi over 4 is? Well, 5 pi over 4 is the pi over 4 angle in the third quadrant. So it's -1 over -1. So tangent of, well, actually, we want cosine. It's going to be negative square root 2 over 2. Okay, so this is going to equal, now once again it's plus or minus, but where is 5 pi over 8? Well, 5 pi over 8, notice pi over 2 is 4 pi over 8. So 5 pi over 8 would be in the second quadrant. So we know that is going to be negative. So watch out for that because you don't want to get caught with the wrong sign. Now, tangent is sine over cosine. So sine is the away team, so it's 1 minus cosine of the angle over 1 plus cosine of the angle. Okay, now, cosine of 5 pi over 4 is negative square root 2 over 2. So this becomes negative square root of, now 1 minus a negative becomes 1 plus square root 2 over 2. And then 1 plus the negative becomes 1 minus square root 2 over 2. All right, so now what we do is we get common denominators on the top and the bottom. So this becomes We'll keep it all 1. So this becomes 2 plus square root 2 all over 2 over 2 minus square root 2 all over 2. So now the 2's cancel, and we're left with the negative square root of 2 plus square root 2 over 2 minus square root 2. Now, we need to get the radical off the denominator. So what we're going to do is we're going to multiply by the square root of 2 plus square root 2 over square root 2 plus square root 2. Now, on the bottom, we have an a minus b times an a plus b, so that gives us the square root of a squared minus b squared. And on top, we have square root 2 plus square root 2, square root 2 plus square root 2. So it's the square root times the square root is just going to be 2 plus square root 2. And the whole thing is negative. Let's just put the negative down here. Okay, so now what I have is this is going to be, oh, I just changed the brown again. We can't do that. It was that brown. That's even worse. I'm not even on brown, I'm on orange. Why didn't you guys tell me that? Okay, so this is going to be negative 2 minus square root of 2, all divided by square root of 2. Now, what I'm going to do is I'm going to multiply by the square root of 2 over square root of 2. So I have 2 times square root of 2. So this is going to be negative 2 square root of 2 minus square root of 2 times square root of 2 is 2. All divided by square root of 2 times square root of 2 is 2. So notice I have a 2 in all three terms, so the final answer ends up being negative square root of 2 minus 1. And that is tangent of 5 pi over 8. Negative square root of 2 minus 1. Okay, so the last one we're going to do is cosine theta equals negative 8/17. Theta is in the second quadrant, and we need to find all of these half angles. So, first of all, we need to look at what cosine theta of negative 8/17 actually means. So, let's do that over here. So, it's in the second quadrant, and the adjacent side is 8, and the hypotenuse is 17. So 17 squared is 289, minus 8 squared is 64. So 289 minus 64 is 225, and square root 225 is 15. Or the Pythagorean identity, or the Pythagorean triple that you know, 8, 15, 17. Now, the 8 is left, so that makes it negative. The 15 is up, so it's positive. So cosine is negative 8/17. Now, the sine of theta over 2 Now, sine, if cosine is in the second quadrant, let's see. Got to think about this for a second. If cosine of theta is here, that means theta goes here. Now, half of theta would be in the first quadrant. So we do know that's going to be positive. Now, sine of theta over 2 is then the positive square root of 1 minus cosine theta over 2, which equals the square root of 1 minus a negative 8/17. So it's 1 plus 8/17 all over 2. And 1 is 17/17, so we have square root of 25/17 all over 2, which means the square root of 25/34. And we can't reduce that, so this ends up being 5 over square root 34 times square root 34 over square root 34 equals 5 square root 34 over 34. That's it, piece of cake. And then cosine of theta over 2 is also going to be in the first quadrant, so it's 1 plus cosine theta all over 2, which equals square root of 1 minus 8/17 over 2, which is 17 minus 8 is 9, so 9/17 over 2, which is square root of 9/34, which is 3 over square root of 34 times square root of 34 over square root of 34. So this equals 3 square root of 34 over 34. And tangent theta over 2, we really just have to go sine theta over 2 over cosine theta over 2. So that means we're just going to go, well, let's just do with the 5 over square root of 34. 5 over square root of 34 divided by 3 over square root of 34, which equals 5/3. That's it. Piece of cake. Have fun with these.